Hey everyone, let's get started today. So today we are going to work on a data set and we are going to do the data analysis and data visualization. So let's get started. So the first thing that we will do is let's have a text cell. Let me delete this. Let's have a text cell and give the heading. The heading is given by hash and I'll write data analysis. Now, since we will be dealing with data sets, we want pandas and sometimes we would need numpy also. So we'll import numpy and pandas as we know in from the previous classes. Import numpy as np and import pandas as pp. Now we already know what numpys is, what pandas is. They are Python libraries and pandas is used to work on data sets and it is built on top of numpy. Now, I have a data set which is stored in my Google Drive in a folder named datasets. You see placement data.csv. This is the data set that we are going to use. So we see that it is very similar to what we have seen in the examples in the previous classes. We have serial number, we have gender, we have some SSCP, SSCB, which are basically some percentage. These are some board, HSCP again, which is percentage, HSCB, which is board, HSCS, which is basically the stream that you have, degree P, again the percentage, degree T, the type of your degree, work experience, e-test, employability test percentage, specialization, MBA percentage, status, and the salary. And if you see, we have some missing values also. And when we bring them in our data set, so here you see them as missing values in the CSV file. When we are going to bring it in our pandas data frame, they will be treated as NANs, not our numbers. Okay. Now, first I want to access this placement data.csv in my Google Colab. So I essentially want access to, basically my Google Colab wants access to my Google Drive. So how do we do that? For that we have to mount the Google Drive to the Google Colab. And there's a fixed way of doing it. From google.colab import drive. And then you have to mount drive.mount and you provide drive. So this is the fixed way of providing access of our Google Drive to our Google Colab. So this says permit this notebook to access your Google Drive files. Yes, we want to do this because we want to access placement data.csv, which is stored in our Google Drive in our Google Colab. So I'll say connect to Google Drive. I'll provide my mail ID and then I will say Google Drive for desktop wants to access your Google account and basically I have to say allow. So now I will be able to access my Google Drive from my Google Colab. It takes a bit of time. So now we see mounted at Drive. Now what we have to do, we have to read the data set, which is basically placement data.csv. Since it is a CSV file, I have to use pd.read. If I say control plus space, I'll be getting options. I'll be getting recommendations on what should I write. So you see read CSV. This is used to read the CSV file. And then I have to give the path of my data set. So first we'll always have to write drive. Then if you see, we have my drive written here. So I want to write my drive. Then if you see, we have data sets, which is our folder name. So write data sets and then we have placement data.csv. We have to exactly copy the same. If you make any mistakes, then it is going to give an error. For example, let me not have the underscore and let me try to do this. It says no such file or directory. So if you don't write everything exact, like there should not be difference in the uppercase, lowercase, there should not be any difference. In case there is difference, we are going to get this error, file not found error. So now we'll be able to read our CSV file. And if you see, here we have NANs, right? If you see the data set, you had missing values, right? Here they are replaced by NANs. Now, let's store this in a variable called df. And now let's see our df. So if you see your df, we have serial number, gender, and so on. That is, we have a lot of columns, we have a lot of records also. And here it shows that there are 215 rows and 15 columns. So there are 215 records and 15 features or attributes. Okay, so let's now do a bit of data analysis. Let's write the questions also. So check the first 4 rows of the data frame. The data frame that we have is df. So how do we first check the first 4 rows or display any number of rows? We do it by head. Head is a function of the data frame or pandas. So basically we have head in pandas, which basically helps us to figure out or return the first few rows. So if I just write df.head, by default it will return 5 rows, the first 5 records. So this head function, it basically returns the first n rows, and by default n is equals to 5. If we say 4 here, then it is going to return only the first 4 records. So we get only the first 4 records. So this head function, it returns the first n rows for the object based on the position. So the first 4 based on their index, the first 4 records which are there will just be displayed. First 4 means basically which are at the top. The top records would be displayed. And by default n is equals to 5, that is first 5 records are displayed. If you want first 4 rows, we have to specify n is equals to 4. You can write n is equals to 4 also, or you can directly write 4. Okay. Now let's see what each of the column basically stands for. Let's understand the columns, then only we'll be able to use these columns and actually analyze, visualize, and build the model. So serial number is essentially just the serial number of students. Gender is what is the gender of the student. SSCP is the secondary education percentage, which is the 10th grade percentage. SSCB, it's the board of education, whether it's central or whether it's others in 10th. In HSC, what is HSCP? HSCB is the higher secondary education percentage, which is the 12th grade percentage. Similarly, HSCB is the board of education of 12th. HSCS, it is the specialization in your 12th. It could be commerce, science, arts, etc. Then degree P. Degree P is the degree percentage. So basically after your 12th, you take a bachelor's degree, right? So it is the percentage of that bachelor's degree. Degree T. Degree T is the undergraduation or the bachelor's degree type, the field of your degree. So it could be science and tech, commerce and management, and so on. Work X. Work X is how much work experience the student has. Then E-Test P, that is the employability test percentage which is conducted by the college. So basically these are the students of one particular college. Specialization, it is the post-graduation specialization, whether it's marketing and finance, marketing and HR, and so on. So after your bachelor's, you have done your post-graduation also. So this is the post-graduation specialization. And MBA P is the post-graduation MBA percentage that you got. Status. Status is basically whether the student is placed or unplaced. So you see placed and not placed. And salary. Salary has basically the salary, if the student is placed, then how much the salary is. If the student is not placed, then we see a NAN here. But we'll confirm if NANs are only there in the salary column, and if they are only in the salary column, when do they occur? Do they occur when the status is not placed, or they can occur even when the status is placed? It may happen that for placed students also we don't know the salary. So we'll do that analysis and then see what imputation we need to do. Now the next question. Get all feature names. So all the attribute or the variable names, we want those. So that can be done by columns attribute. So you just have to write columns. You see, columns. And it is going to give you all the column names, serial number, gender, SSCP, and so on. Then the next is find the number of records and columns. So again, we have an attribute called shape which can help us do this. So it is going to give 215 records and 15 columns. If let's say I just want the number of records, find the number of records in the data set. So I can use df.shape. Shape is an attribute which gives us the size of the data frame. But I only want the 0th element in the shape also. So it will be df.shape 0. So it will give us 205 records. If I want columns, I have to use df.shape 1. Now the next one, find the data type. Find the data type and number of null entries, or let's say non-null entries in all columns. Find the data type and number of non-null entries in all columns. So basically there's something called as info function. So we are just understanding a few functions of the data frame. We discussed first head. Head basically returns the first few records. Then column, it gives us all the columns. Then we have shape. Shape and column are attributes. They are not functions. Shape basically returns the number of records in columns. And then we have a function called info, and we invoke it on the data frame like df.info, and it is going to return the data type of all the columns, and it will also return the number of non-null entries in all the columns. So if you see, we have serial number, gender, SSCP, SSCB, all of these are columns. For each column, it is written how many non-null entries are there. We have 215 non-null entries in serial number. And how many total records do we have? We have 215 records. And there are 215 non-null entries. That means there are no nulls in the serial number. And the data type is int64 of the serial number column. Moving on to gender. In gender also we have 215 non-null values. 215 non-null values means there are no nulls. And the data type is object. Now this cannot be directly given to our model because the data type here is object. Similarly here for SSCB. Similarly here for HSCB. Similarly here for HSCS. So wherever we have object, we first need to convert it into numbers. Then only we can build a model. So this will come as a part of data pre-processing. Now, if you see, we have here in salary 148 non-nulls. That is, there are some null values here. How many null values are here? 215 minus 148. That is 67 null values are there in the salary column. And salary column only has null values. There are no other null values. In no other column there are null values. Only the null values are there in the salary column. We'll see what we need to do with them. Either we can remove these remove these 67 records, or we can do the imputation. Here we shouldn't do the removal of the records. The reason is we have only a small data set. If we remove 67 columns, that is if we remove 67 by 215, that is 31% of the data. The data is small and we are removing 31% of the data. So that should not be done. So we will not be removing the records, but we will be doing the imputation for them. And here it's mentioned that float, basically the data type for 6 columns is float. 1, 2, 3, 4, 5, 6. Only for one column it's int64, and for 8 columns it is object. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So basically we have figured out how many null entries are there in each column, and we have also figured out the data type of each feature. Now the next, what is the average secondary education percentage? So basically for all the students, what is the average 10th marks? So if you see, 10th marks are given by what? They are given by SSCP. So we have to take the SSCP column, DF, SSCP, and then you have to find out the average. So average can be figured out by the function mean. So for that column, you just invoke the function mean, and average 10th marks are 67%. Okay. Now let's move ahead. What is the max secondary education percentage? So we now don't need the average, but we need the max. So again, we take the column SSCP, and then we have to call just the function max, right? So 89.4 is the maximum 10th grade percentage. The next question, how many toppers were there in 10th or secondary education in 10th? So basically this means that how many people got the maximum marks in secondary education or in 10th grade. That is how many people got 89.4%. So the max secondary education percentage is 89.4. So how many people were there who got max marks, that is 89.4? So we take SSCP, that is the 10th grade. We take that particular column, and we have to check whether it's equals to the max value or not. What's the max value? We can directly say 89.4, but here we'll use this, okay? Because max could change. So if we do this, then we'll be able to figure out for each record if the 10th percentage are equal to 89.4 or not. So if we get a false, that means for the first record, SSCP is not equal to 89.4. Similarly for the second, we will get only true when the SSCP or the 10 percentage marks are equal to the maximum, that is 89.4. So if we take a DF of this, we are only going to get those records where this is true, where this condition is true, that is where the 10 percentage marks are equal to 89.4. So this is the one, right? Now I need to figure out how many people were there. Obviously I'm able to see that there's only one person with marks 89.4 in the in the 10th, but I can take the shape of this, and since I need the number of records, I can just take 0. So basically there's one topper in 10th. Okay. Now, is the student who got these highest secondary education percentage, is he placed or not? Is the 10th topper, 10th grade topper, placed or not? So basically we want that same person. We first check for SSCP. It should be equals to the max SSCP, and then we have to take the DF only for those for whom the condition is true. And then we just need to take which column? Status column. That's it. So yes, he is placed. So the 10th grade topper is placed. That is, at least the topper seems to be placed. Let's check for the 12th grade. Is the 12th grade topper placed or not? So we have to use the same, it's just that the column would change. Instead of HSC, SSCP, we are going to have HSCP, higher secondary education. He is also placed. So basically the topper of 10th grade and 12th grade are placed. That's something that we have figured out, which is interesting. Okay. Now let's move ahead. Now we want to figure out how many students are placed and how many are unplaced. So this we can get from a function which is called value counts. We can use a function which is called value counts in Python. It basically returns a series containing count of unique values. The resulting objects will obviously be in the descending order so that the first element is the most frequently occurring element. And this excludes the null values by default. So obviously our placed column does not have null values, but in case there are null values, they will be excluded. So what does the value counts return? It returns a series containing count of the unique values. So basically I want the status column and I have to just call value counts. Let me do a value, just write value and do control space. It should give suggestions. Value, then do control space. Sometimes it doesn't, but it should give suggestions. So actually it's value counts like this. So basically it gives us what? It returns a series containing count of unique values. So basically placed, how many placed students are there? 148. There are 148 records which have the status as placed, and there are 67 records which have the status as not placed. And the resulting objects are obviously in descending order. That is basically 148, whatever is the highest count, that particular unique value will be written first. So the resulting object will be in descending order so that the first element is the most frequently occurring element. Okay. Now let's move ahead. The next question that we have is, what is the most common degree of, let's say, placed students, of placed students? What is the most common degree of the placed students? Now we only have to take the placed students and figure out what the common degree is. We'll use value counts here. We'll try to use value counts. So first we want only the placed students. So df status should be equals to placed. Placed should be exactly how it is written in your data set. If you write it as small p, then it's not going to give you the same answer because you are checking for the exact string. If you write like this, you will get all false. If you take the df of this, you won't find any record, right? So it has to be exactly how it's mentioned in your data set. Now, so df status, we figure out only the placed students. And to do that, I just take the df of this, that is only those records where the status is placed will be shown. You see there are 148 rows that are seen. Now, I have to figure out the most common degree. So basically I need the degree t. So I take the degree t column. I just take the degree t column and now I want to figure out the most common degree. Now value counts is what? It basically returns the count of unique values. So if I do a value counts here, it will tell me how many people have what degree. So 102 people have commerce and management, 41 people have science and tech, and 5 people have others. And this is the data only for the placed students. Now since I only want the most common degree, that is the first one only, I can just take the head of it and just head 1. That is only return 1 first object. So commerce and management, and it's 102 people have got that. Okay, now let's move on to one more function, which is NUnique. So for that, let's have the question: how many unique degrees are there in the data set? So again, we are talking about degrees, unique degrees. So we are talking about degree T. Now I want to figure out how many unique degrees are there. We are trying to figure out number. So first let's see what unique function is. Unique function on a particular column will tell us it will give us a array which will have all the unique attribute values, all the unique degree T values. And if you write n unique, it is going to give you the number of elements in this unique array. It is going to give you the number of unique attribute values in the column. Yes, so basically there are 3 unique degrees in the data set. Now we have also discussed about correlation, right? We have discussed about correlation. Let's revise correlation. So correlation coefficient ranges from -1 to 1 if the correlation coefficient is positive. That means there is positive linear relationship. If the correlation coefficient is negative, that means that there is negative correlation. If the correlation coefficient is 0, that means that there is no relationship, no linear relationship between x and y. And if correlation coefficient is 0, it only means that the two attributes don't have any linear relationship. They can have some polynomial relationship, logarithmic relationship, any relationship. So if it is asked, tell true or false, and the question is, if correlation coefficient is 0, then the two attributes are independent / have no relationship between them. So is this statement true or false? This statement is going to be false. Why? Because if correlation coefficient is 0, it means that the two attributes don't have any linear relationship, but they can have some other relationship like polynomial, logarithmic, etc., etc. Uh-oh. False. Yes. So now, first of all, we can find out the correlation only between the numerical values, numerical columns. So if you want to figure out the correlation between HSCB and HSCC, that's not possible. We can only find the correlation between the columns which have numerical values. So df dot CORR. So CORR is a function which helps us give the correlation matrix. What does correlation matrix mean? Correlation matrix essentially means that if, let's say, there are three unique columns that we have, and which have numerical values, that is they are continuous variables. So what do we do is we write xyz here and xyz here and create a matrix, a 3 cross 3 matrix. If there are 3 continuous variables, then we'll have a 3 cross 3 correlation matrix. If there are 4 continuous variables, we'll have a 4 cross 4 correlation matrix. And this entry will basically tell us the correlation between x and x. Now the correlation of one attribute with itself will always be 1. So this is going to be 1, this is going to be 1, and this is going to be 1. Because if x is increasing, then x will increase with itself, right? So if you plot x versus x, they will exactly be like this. So the correlation coefficient is going to be 1. So correlation coefficient of an attribute with itself is 1. Now the correlation coefficient of x with y is, let's say, a. It will be the same as here, that is the correlation of x and y is equals to correlation of y and x. Similarly, correlation of x and z will be equals to correlation of z and x. Similarly, correlation of y and z will be equals to correlation of z and y. A, B, C can be any values between -1 and 1, and -1 and 1 both included. Okay. Now, let's see the correlation matrix. So we basically have the correlation of the continuous columns, which are serial number, 10th percentage, 12th percentage, degree percentage, employability test percentage, MBA percentage, and salary. And if you see degree P versus and HSCP, the correlation value between degree P and HSCP is 0.434206. If you see the correlation between HSCP and degree P, it is the same. So here and here, it's going to be exactly the same. So in this correlation matrix, can you figure out what is the maximum correlation? Let's only talk about the magnitude. So the maximum that I see is obviously it's 1, but 1 obviously correlation of a attribute with itself will be 1. So you have to ignore 1 and tell another maximum value. So I see 0.538. So I think this is the maximum. So the maximum correlation that we have is between degree P and SSCP. So this tells us that the attributes don't have high linear relationship. So maybe the linear models might not be the best for this data set. And we also have some features which have negative relationship. The negative relationship, if you see here, is minus 0.019, a very weak negative relationship between salary and degree P. And in our data set, we can have status or salary as the target. If salary is the target, then basically we are doing regression. If status is the target, then we are doing classification. And status and salary will depend on all these: gender, SSCP, HSCP, and so on. So if status is the target, it's classification. If salary is the target, it is regression. Now, if you see the correlation of salary with all the continuous variables, obviously serial number won't matter because we are obviously going to delete it since it's an irrelevant feature. Here the correlation is less, here also it's less, here also it's less, here also it's less, here also it's less. Obviously salary with itself will be 1. So if you see, salary is not highly correlated with the other numerical attributes. It's not very highly correlated. So this tells us maybe linear models might not be the right model here, because salary, the target, is not highly linearly related with the others. Obviously we'll do the encodings and then see the correlation also. How does the correlation look like then? Because here we are only considering the continuous variables. We still have the categorical variables left. That is, we have to encode them and then we can see. But for now, salary does not have lot of correlation with the continuous variables. Okay, that is pretty much some simple data analysis that we've done on the data set. Now let's do a bit of data pre-processing. We'll do a bit of data pre-processing and then start off with the data visualization, and other data pre-processing we can continue later. So first of all, identify the column which can be removed. Let's remove only one. So let's see our DF. So our targets are status and salary. And obviously serial number does not affect our status or salary in any way. So we can drop that. So for that, to drop a column, we use drop function. We can specify the columns. We can specify the columns like this. And here we provide the name of the columns, which is serial number. And let's run this. If we run this, you will see that what In the data frame that is displayed, we don't have serial number. But if we see DF again, you will still get serial number because we have not set in place is equals to true. And if in place is equals to false, which is the default, then the operation is performed and we just get the copy of the data frame, but the data frame would still have serial number. The data frame would still have serial number. So we have to set in place is equals to true. So when in place is equals to true, the data is modified in place, which means it will return nothing and the data frame would be updated. Whereas when in place is equals to false, then the operation is performed and it returns the copy of the data frame. So we have in place is equals to true, nothing would be returned, but when you see your DF, your serial number is gone. That's what we wanted. Okay, now we check the number of null values in each column. So first of all, we'll have the function which is null. So basically in our data frame, for every cell, we are going to check whether it's null or not. If it is null, for that particular cell, we'll get a true, otherwise we'll get a false. So if you see, we have male here, which is not null. So it's not null, so we get a false, and similarly. And then if we take the sum of it, then we are going to get basically the number of null values in each column. So for gender, we have 0 null values. For SSCP, we have 0 null values. For SSCB, we have 0 null values, and so on. And if you see, the only null values are in salary. Okay, so now we have to either remove these records or do the data imputation. Now we already discussed that the number of records we have is less and we cannot further decrease the records because already the data set is small. We cannot lose 31% of the information. So we are going to do data imputation. That's what we are going to do. Now, let's figure out, let's have the next question. Fill the missing values with appropriate value and then check the number of null values in each column. So let's first check the salary is null for what students? Are they placed or are they unplaced? So let's check DF. We take the status column. Now the status column will have placed or unplaced. So then let's check the placed students. And let's see if there are any nulls here. So we take the placed students, we take the DF of it, the entire data set, and we check if nulls are there or not. If nulls are there or not. You can check for this only, placed only. Let's check like this, is null, okay? And then you do the sum. So you see, no placed student has null values. Let's say not placed, right? And see. Now if you see 67 people who were there which had null values, those same 67 people are actually not placed. Those 67 people are not placed. So this tells us that all the not placed students actually have the salary as not a number. So for unplaced students, what should be the salary? Should it be the mean salary or the median? No, it should not be. It should be zero. Obviously, unplaced students will have what salary? Zero salary. So we are going to fill our nulls with the value 0. So let's have df dot fill. Let's do a control space, fill NA, and then fill the nulls with 0. Now if you see, the nulls would be filled by 0. But if you check your df, you'll still get the nulls because you have not set in place is equals to true, and by default in place is equals to false. So you have to set here in place is equals to true. And now if you check your df, now you won't see NaNs, and instead of NaNs you see a 0. Now if you check df dot is null dot sum, you'll get all zeros. So now there are no null values. Now we don't have any null values, and now we can start with the data visualization. So first we'll do the data visualization and come back to data pre-processing after it. Data visualization. We already discussed that there are two techniques in data exploration. One is called the summary statistics or the descriptive measures, and the second is data visualization. We discussed a few descriptive measures like the mean, max, and so on. We also discussed correlation. Now we are going to go and discuss data visualization. Okay. Now for data visualization, we have different libraries in Python. So first of all, what is data visualization? Data visualization is the graphical representation of the data. It converts huge data set into just small graphs, thus helping us in data analysis. And there are two Python libraries which help us in data visualization. They are matplotlib and sequon. Let me write it. Two Python libraries for data visualization: matplotlib and sequon. So matplotlib is the Python library which is used for plotting graphs with the help of other libraries like lumpy and pandas, and it is a powerful tool for visualizing data in Python. And sequon is also used to plot graphs, but it is an advanced version of matplotlib. So matplotlib is used to make basic graphs. Let's differentiate them here. Matplotlib and sequon. So this is used to make basic graphs, and this is used to make advanced graphs. Okay. So here the code that you have to write to make a graph is high, and here we have simple syntax and less code that we have to write. Okay. Now, sequon is actually an extended version, or you can say an advanced version of matplotlib. Okay. Matplotlib works efficiently with data frames and arrays, and sequon is much more functional and organized than matplotlib and treats the whole data set as a single unit. So this is kind of an extended version, right? So if someone asks you what's the difference between matplotlib and sequon, two things that you definitely have to say is this is used to make basic plots, and sequon is used to make advanced plots. And in matplotlib, the code that we have to write is high, and the syntax is not so easy. It's lengthy and complex, whereas in sequon we have simple syntax and less code that we have to write to make the graph. And sequon is kind of an extended version of matplotlib. Okay, so now we'll import these. So first we'll import matplotlib dot pyplot as plt. This is the recommendation that we get, and we'll use this. Now if you don't use pyplot here and you just import matplotlib as plt, then always you'll have to write plt.pyplot, because all the plots are there in matplotlib.pyplot. That's why let's use directly, let's directly use import matplotlib dot pyplot as plt, so that we don't have to write pyplot again and again, because all the plots that are available are in pyplot inside matplotlib. Okay, now how do we import cborn? We import cborn as sns. Okay, now the first graph that we'll make, draw a scatter plot between 10th and 12th percentage marks. Okay, so we draw the scatter plot between 10th and 12th percentage marks. Now the first question is, what is scatter plot in general, and obviously here also? So it is a diagram where each value in the data set is represented by a dot. For example, let's have a simple scatter plot. Let's say there are two features x and y. For these are the values of a few objects. So each value, each data object will be represented by a dot. So 1, 2, 3, 4, 5, 6, 7, 8. Similarly 1, 2, 3, 4, 5, 6, 7, 8. So first is 1 comma 2. So 1 on x, 2 on y. Then 3 comma 5, which will be here. 6 comma 8, which will be here. Then 2 comma 4, which is here. So basically this is the scatter plot for these 4 points. So each value in the data set is represented by the dot in the scatter plot. Now, how do we draw this scatter plot? So we use PLT, which is the pyplot, which is the matplotlib. PLT dot, there's something called as scatter. Scatter is going to be the function that is used to make scatter plots. And here you have to first provide what you want on the x-axis. So on the x-axis, I want the column SSCP. So basically the column that is needed on the x-axis should be provided first, and the column that is needed on the y-axis should be provided as the second argument. So first I give the column SSCP. Why I'm giving df SSCP? Because I want the entire column values, all the attribute values in this column to be on the x-axis, and on the y-axis I want HSCP. Let's see what happens. So if you see, we are able to get scatter plot, and each dot represents a data point or a data object. Now, if you see this, you will not be able to understand what is on the x-axis and what's on the y-axis. Obviously, since we have made the graph, we know that 10% is on x-axis and y% and 12% is on the y-axis. But for others, we should provide the labels also. So to write something on the x-axis, like below the x-axis, we have something called as x label. And here I write 10th percentage marks. Then we can give the y label also, and this is 12th percentage marks. So now we have the 10% and the 12% marks. This is written here, so now it's easy for anyone to understand what's on the x-axis and what's on the y-axis. We can also give the title to the graph. So scatter plot between 10th and 12th percentage marks of students, like this. Okay. So now what you see? Do you see that there is some positive correlation? There's some positive correlation. And we also knew the correlation value, which was SSCP and HSCP. So it was, yes, there is some positive correlation. Not a very strong positive correlation, but there is positive correlation. So that is, if 10% is increasing, 12% is also increasing for some students. The person who got the minimum the minimum 10th percentage marks also got very less 12 percentage marks. Not the minimum, but he got less. And the person who got the minimum 12 percentage marks, this one, has also got some less 10th percentage marks. Not the minimum, but he has got less 10th percentage marks. So these are the insights that we can draw from each of the graphs. Similarly, the person who has got the maximum 12 percentage marks was not the person who got maximum 10th percentage marks. So the person who got max 12 percentage marks, he had less than 80 marks in 10th. And the person who got the max 10th percentage marks, he also got less than 70 marks in 12th. So basically, the person who got max in 10, he did not perform well in 12th, and the person who got max in 12 did not perform well in 10th. So these are the insights that we can draw from the graph. Now, the next question. So we draw the scatter plot between 10th and 12th percentage, but we group the points based on their placement status. So draw the scatter plot between 10th and 12th percentage of students grouped based on the placement status. So basically we want the placed students to be highlighted with one color and unplaced students to be highlighted with another color. We can do this in this same matplotlib graph, and for that what we have to use is the same. We have to use scatter plot only. We can obviously do it with Seaborn also, but first let's do it with matplotlib. And in scatter plot, we can use the same scatter plot function, but we just have to provide one more thing, which is C. It is the color of sequence of colors for markers. So let's see. We can do the same. Let me just copy the first line. And C is going to give you the color of sequence. Basically, for placed students we want something, for unplaced students we want something. So this is denoted by C, which is the color of sequence. Okay, so here what should we provide? Now since we want, let me first have another coding cell. See, how can I give colors? I want to give the colors based on the status. So let's say if the status is placed, I want the color blue. If the status is not placed, I want the color red. So for that, what I can do is, first let's have a colors dictionary. So if the status is placed, if the key is placed, I want the color as tab blue. So to provide the colors, we have to use tab. Okay, so then only we'll be able to get the colors in the graph. Then for not placed, I want the color tab red. Okay, and then what I have to do is, I take the status column. Right now you see placed and not placed written, right? Placed and not placed. But I can have a function which is called map. What will this map do? In this map, if let's say I provide colors, so what will this map do? In this map function will actually, wherever placed is written, it will replace it by the value tab blue, and wherever not placed is written, it will replace it by the value tab red. So what does this map function do? It maps the keys to the values. So now instead of placed, we get tab blue. Instead of not placed, we'll get tab red. Now this can be used as my coloring scheme. So I can use this. So now if you see, we have got colors, red color and blue color. So red is for not placed students and blue is for the placed students. And now what we can interpret from this graph, the not placed students have got less 10th and 12th percentage marks as compared to the placed students who have got better 10th and 12th percentage marks in general. So this is something that we can figure out from this graph. Now let's draw another type of graph which is called pair plots. Let's say we have three continuous variables. That is, we have three columns which have continuous variables. Okay. Now, what are pair plots? Pair plots essentially means the graph between each pair of the continuous column. So we have x here, then we have x here. Similarly, x will be here on all the y-axis. Similarly, y will be there on all these axes, and z would be there on all these three graph y-axis. Now here we'll have xyz, similarly xyz, and similarly xyz. So basically we have 9 graphs made. So if there are three continuous columns, then we have 9 graphs. If there are 4 continuous variables, we'll have 16 graphs. Now each of them will be a scatter plot. So basically pair plots essentially means we are making scatter plots between all the possible pairs of continuous variables. So this will be a scatter plot, this will also be a scatter plot, this will also be a scatter plot, this will also be a scatter plot, similarly like this. Now obviously x versus x will actually be a straight line. So it does not make sense to just have a straight line, right? It will always be a straight line. So instead of that, what do we have here is a histogram. We have a histogram, right? Now what is a histogram? What does a histogram mean? It is a diagram which consists of rectangles. It's a diagram which consists of rectangles whose area is proportional to the frequency of a variable and whose width is equals to the class interval. So this you would have drawn something in your previous classes, like in your 10th or 12th class, but I'll discuss histogram in a bit detail in the next class. Okay. So instead of having the straight line, we'll have histograms here. Okay, we'll have histograms here. Okay, so now let's draw these scatter plots. We can easily draw these scatter plots using the library Seaborn. So the question is draw the pair plots between all continuous columns. So we'll say SNS dot pair plot df, and let's see, it's going to take a bit of time. Let's see, it takes some time because there are a lot of graphs that need to be made. For this small data set also it takes time. So imagine for a very big data set how much time it's going to take. So you see SSCP versus SSCP would be a histogram. Similarly HSCP versus HSCP would be a histogram. And then you see we have all the scatter plots for all the pair of continuous variables. Okay. Now, we can set something called as hue here. There's something called as hue here. Let's see. SNS dot pair plot, we give the data set, but we also provide the hue. Hue is basically the variable or the column to map plot aspects to different colors. So basically it tells us the coloring scheme. So for example, if I set the hue as status, it is basically the column which is going to give different colors to different points. So basically the coloring would be based on the placement status. For not placed students, the color would be different. For the placed students, the color would be different. Let's see. Again, it will take some time. Yes. So we have the scatter plots, and you can now analyze all these scatter plots. Why are we getting a lot of points here? Because on the x-axis we have salary, and salary is 0 for many points. That's why we are getting these lot of points in this vertical line. Now, if you see, these histograms have been replaced by something like these. So what are these? These are called as kernel density estimate. So KDE. So basically what does this mean? It basically estimates the distribution from which SSCP is coming for the placed students also, and for the unplaced students also. And it's written that blue is for placed and orange is for not placed. You can change the coloring scheme also, but I'll leave it on you to figure out how do you do that. There are lots and lots of options available in pair plot. So you can explore all of them. Okay. So now if you see the blue is basically the distribution. The distribution from which SSCP is coming for the play students, and this is the approximate distribution. These are approximate distributions, okay? So this orange distribution is the approximate distribution of SSCP for the unplaced students. Okay, so if you don't write hue, you'll get a histogram, but if you write hue, you are going to get a pair plot. If you want to change, like if you don't want these KDEs and you want to again have your histograms only, even with the hue, you can do that. For that, you just need to have die kind, that is diagonal kind should be histogram, which is you write it as hist. So you will get the histograms back. So KDE is what? It is the kernel density estimate, and basically what does that exactly mean? It's the distribution from which our variable is coming from. It's the approximate distribution. Okay. So we will stop here, and in the next class we are going to do more of the graphs. Okay, we'll understand a lot of other graphs, for example line plot, then we'll understand box plots, then we'll understand heat maps, histograms, and so on. So that's it for this class. Thank you everyone.